Predicting solar eclipses remains a monumental challenge even today, with our advanced supercomputers, satellite networks, and precise orbital models that crunch vast amounts of data to forecast these events down to the exact second. Yet, astonishingly, over 1,000 years ago, the ancient Maya civilization in Mesoamerica accomplished this incredible feat without telescopes, satellites, or even a single sheet of modern paper. They relied solely on patient naked-eye observations and ingenious pattern recognition. How did the Maya, armed with their profound and intricate knowledge of the cosmos, achieve such a mind-blowing accomplishment that still impresses modern astronomers? Get ready to buckle up and hold on tight, because we're diving headfirst into a captivating journey through the wonders of ancient astronomy and the Maya's stellar genius.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
The Maya weren't some mystics peering into crystal balls or consulting oracles. No, they were the ultimate data scientists and meticulous skywatchers of their era, with priests and astronomers dedicating entire lifetimes, spanning centuries, to carefully observing and recording the precise movements of the sun, moon, planets, and stars right from the lofty summits of their massive, towering pyramids that pierce the jungle canopy. Picture their notebooks, not today's sleek laptops with infinite storage and AI assistance, but fragile bark paper codices, laboriously inscribed by hand with thousands of glyphs and numerical records, and let's be real, definitely no autocorrect to fix those intricate hieroglyphs when a quill slipped during a late-night stargazing session under the stars. To truly appreciate their genius, let's quickly recap the basic science of eclipses that they mastered through pure observation. A solar eclipse occurs when the moon glides directly between the sun and Earth, casting its umbral shadow across our planet's surface for those magical moments of daytime darkness. A lunar eclipse, on the other hand, happens when Earth positions itself between the sun and moon, with our planet's shadow engulfing the moon in a coppery glow. The crucial factor is not just perfect alignment, but also the moon's orbital plane, which tilts about 5 degrees relative to Earth's orbit around the sun, creating specific nodes where crossings enable eclipses. The Maya didn't grasp modern orbital mechanics or gravity, but they excelled at detecting repeating patterns in the sky's dance, because as any scientist knows, true discovery often begins with that excited exclamation, "Hey, that happens again. Let's track it." At the heart of their predictive prowess was the Dresden Codex, one of the miraculously surviving 4 Mayan books that escaped the fiery destruction by Spanish conquistadors, serving as their ultimate cheat sheet. Packed with detailed eclipse tables that meticulously charted the cycles and periodicities of both the moon and sun over vast spans of time. This treasure trove wasn't focused on unraveling the underlying why of eclipses through physics, but laser-targeted on the practical when, pinpointing recurrence intervals with such reliability that it allowed them to anticipate events months or even years ahead, which, if you think about it, is brilliantly pragmatic when you're charting the heavens without a supercomputer or even a calculator in sight. Through relentless observation, the Maya pinpointed that a synodic month, the interval from one new moon to the next, clocks in at approximately 29.5 days, and they astutely identified eclipse seasons recurring roughly every 177 days, a period that neatly aligns with about 6 synodic months. By cleverly stacking these cycles atop one another, along with other harmonic numerical patterns like multiples of 13 and 20 from their vigesimal system, they constructed reliable forecasts for when eclipses were most probable. It was all observational mathematics at its finest, no need for Newton's laws or Kepler's ellipses, just extraordinary patience, sharp eyes, and an intuitive feel for the cosmic rhythm pulsing through the night sky. Of course, their predictions weren't laser-precise to the exact minute or path like today's GPS-guided models, but instead offered practical windows of opportunity spanning days, which was still leaps and bounds ahead of anything achieved in Europe before the era of Isaac Newton and his revolutionary calculus. The sheer precision they attained purely through centuries of dedicated skywatching and data logging underscores their unwavering commitment to astronomy, proving that sometimes the simplest tools, eyes, patience, and patterns, can unlock the universe's deepest secrets. Here's a delightful pattern-interrupting fun twist to blow your mind. The Mayas' eclipse mathematics was so robust and finely tuned that many of their calculated intervals align uncannily well with elements of our modern Gregorian calendar systems, as if these ancient stargazers were pros setting up celestial appointments that echo perfectly even today, centuries later. For the Maya, solar and lunar eclipses transcended mere astronomy. They were potent omens believed to imperil kings, crops, and the very fabric of social order. So mastering their prediction bestowed immense ritual power and societal stability upon their priestly class. This saga reminds us that raw data and tireless observation often outshine lofty abstract theories, and the Mayas' patient vigil over the heavens truly conquered the cosmos' enigmas. If you loved this dive into ancient scientific wonders, give this video a like and subscribe for more thrilling tales of history's hidden geniuses.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.